Hi everyone, my name's Dan Saunders. I'm a product manager here at Basemap, and I'm here today to chat to you about how our TRACC software is helping out various universities in their day-to-day kind of travel planning work. And I'm going to be talking through some examples and some case studies of how universities are using our software. So hopefully as a university you're trying to answer these sorts of questions. These are sort of things that we keep coming across all the time. So first and foremost, as a travel planning coordinator or something like that in the university, your main aim is to ensure that people actually get to the university, ensuring that the sites are accessible, by public transport, by walking and by cycling. Also part of that, you may be having a role where you've got to start delivering, sustainability or carbon emission kind of production policies. And part of that can be trying to promote modal shift from people that might be driving into the site to maybe walking or cycling or using public transport as part of that. And the great thing is by committing to this kind of modal shift kind of methodology, you can very easily reduce emissions as part of that. It's quite an easy win, and that can very easily go into your HESA reports as part of it. There's also a knock-on effect. Lots of people are also very keen to promote modal shift to improve active travel, and there's a lot of links towards active travel, so people cycling and walking into the university or place of work actually puts them in a better state of mind when they arrive. So students come more engaged and ready to learn, and staff come already kind of switched on and ready to start teaching or ready to go about their day-to-day job. Also, many of our clients, many universities will part fund or will fund a bus route. It might be a Unilink service or might go towards the local council. But lots of times they don't really know, are they getting the best kind of value for money for them bus routes? They need a software or a tool that can help you analyse where your bus services go and are they operating efficiently. And also it's very important when looking at kind of modal shift, a lot of things are being done around parking on that. So actually putting in a policy in place that says you can't drive in if you within a 20-minute walk or a 20-minute cycle or something like that. A big part of that is having a really kind of consistent and robust and also transparent evidence base you can build things off. And this is the type of things where software can definitely help clients out as part of it. And the thing, picking up on the kind of the robust and kind of accurate. So we did a talk recently with a university who were using a crow flies approach. And then when they tried to bring that in and try to do a policy off the back of it, people kind of laughed them out the door. So an example here is Southampton. And we've at the moment got a kind of circle that's representing 1 mile distance from a central site, it's actually St Mary's football stadium, and we can see here there's a river that runs through the middle of the map called the River Itchen, and using this type of approach people can basically walk over rivers, they can walk through buildings, and it's not a very accurate way of looking at stuff. We're going to come back to this map later on, but for the moment just kind of keep in your memory this figure of just over 42,000 people as actually the amount of people that are covered within a 1 mile catchment of this crow flies methodology. So what you should always try and look at doing is using a software or a tool to try and make this more accurate for yourselves. And our software tool we're trying to promote is our TRACC software. And TRACC is a really kind of groundbreaking tool where it allows you to analyse all modes of transport. So what we mean by that is you can look at public transport via timetables of buses, trains, trams, tubes, cable cars. You can analyse travel time using all of them modes by looking at different times of day and looking at the timetable as part of it, as well as your traditional car, cycling and walking methodology as well. Then what you can do as well very easily is start doing the what if scenario. So what if we add some new roads in? What if we change a road, say the A38, we stop people cycling and walking on it because we think it's dangerous? What's the knock-on effect for travel time? Or if we change our U2 university service and we remove a couple of stops or we divert it across somewhere else, what's the knock-on effect? Is that going to have an improvement in travel time, or is that going to have a negative effect on that? With all these things as well, it's really important to have accurate kind of outputs from the system as well. So what we've got is a travel time map in the bottom left. This is showing walking to an educational site, showing 5, 10, 15, 20-minute walking bands. And then what we've done is you've overlaid the actual walking routes that are undertaken. So if we look at the purple example at the bottom, as the crow flies, it doesn't look very far, but actually when you start taking it around the curvature of the footpath and road network, The distance actually is about 3.5 times more than actually the crow flies methodology. And this is a really important thing to kind of highlight of why kind of the crow flies doesn't work. What we've also got is a map on the right hand side, and this is showing actually if you live in a specific area, what's the closest destination, what's the closest halls of residence, what's the closest campus for us to use public transport to get to. So that in the areas that the blue dots, a particular destination is closest. If you wanted to, you can delve into much more detailed reporting out of the system. So you can bring out a database effectively showing you all the travel times from origins to destinations, and you do many of them. So an origin could be a postcode and a destination might be a campus, for example. And then what you can also do is you can start bringing in things like demographic data. So if you, as a university, are looking at opening up a new campus or a new site and you have a few different bits of land to choose from, you can use demographic data to find out which is the most accessible for, say, people in full-time education or anything like that as well. So it brings a lot across lots of really accurate data to give you a really robust evidence base at the end of things. So if we take the TRACC software and we take the great data it can utilise, we plug it back into our Southampton example we showed a minute ago, we can see what 1 mile actually looks like when you take into account the curvature of the footpath network, the road network, and natural barriers such as the River Itchen. And what we can now see is the blue area is a much smaller area of coverage, so only covering just over 15,000 people now. So it's just over a third that was covered by the crow flies distance, giving a much more accurate representation of what 1 mile actually looks like. And then what you can do is very easily see, well, okay, well, let's improve that. Let's put a new footbridge across the river. Let's see what the knock-on effect is there. So what can be done very, very simply and very quickly is a footpath has been put across the river showing an increase in the 1 mile catchment. And then that's then showing in the demographic data showing an extra 4,000 people are now able to access that site. Again, all this is really quick and simple to do within the software. From start to finish, this process took less than an hour. So this is exactly what kind of universities are doing at the moment. So a couple of recent projects that of universities have used the tool, it's been Kent and Reading, and they effectively wanted a very, very simple view of how staff and students are travelling to their sites. So what they did is they plotted all the postcodes of staff and students, and then they generated transport travel times via public transport, walking and cycling. And that gave them a really strong and robust evidence base that they could then inform the transport plan for the university and work out areas where it could be improved as well. And the big part of that was trying to promote modal shifts, so people that might be driving in, they might not know that they could get the bus in that takes them not as much time as they thought. And the great thing about that is promoting the modal shift then helped them reduce carbon emissions, which they could then bring into their reporting, because they'd actually be getting the distances out as well, and they can very easily apply a weighting of emissions per kilometre travelled. A more integrated solution was what Cambridge have done, and what they've done is they've used TRACC with some key stakeholders around the city to create what they call a total transport plan. So what that effectively means is they've worked with Addenbrooke's in the NHS, one of the largest employers around, as well as their local councils and other employers around, to look at improving access to all of these main sites that everyone wants to go to look at putting in new cycleways, new walkways, and adjusting the public transport networks to ensure that they're actually getting people to the right places. It's quite a groundbreaking way of looking at things, but actually by getting all these key stakeholders into a project together, it actually can get the decisions made and get transport improved very quickly and reduce things such as emissions as well. And a really important thing here was giving them the ability to start editing that network. So there's lots of new development going on as well. So what if we put a new bus route in, or what happens if we divert a bus route? What's the better option? And looking at doing all that type of analysis as well. So these are the typical type of examples that can be done from the software. So this first thing we're seeing at the moment is again in Southampton, showing a cycle time. And this cycle time is showing a 5-minute, 10-minute, 15-minute and 20-minute cycle time to the campus and any one of the 3 kind of entrances. Then what's been done is just overlaid where the postcodes of students are located, and you can then very easily see where there's a cluster of them, and also what their likely travel time is as part of that. And that can give you a basis then to say, right, let's put a new cycleway in, or let's put some secure bike lockers here. And this gives you a great evidence base to look at that. We can also then look at maybe walking. This is again showing walking up to 30 minutes, again to the campuses in Southampton, so the area that's pink is up to 10 minutes, blue is up to 20 minutes, and the green colour is up to 30 minutes. And you can see again, it's not a complete circle. It kind of comes off due to the curvature of the road network. It's not a proper bullseye effect. You can see where it's curved based on where people can and cannot walk. And then we're really coming to our own and start looking at public transport data as well. So this is the simple map showing where all the bus stops are located around the campus. And then behind these stops, you've got all the timetable and all the services, so you can tell which bus services are calling where and how long it takes to get between these stops. And having that information gives you some very detailed output. So what we've got here is a public transport map showing 5 minutes, 10 minutes, 15 minutes, and 20-minute public transport commuting times to any one of the entrances of the site. And it looks okay at the moment, but you can see there's a few kind of barriers in and around the city at the moment. So you can do the what if scenario. So what if we start extending some bus routes that come out of the city? What if we start, adjusting our Unilink services? Can we get a much greater area of coverage? So again, with the same 20-minute bands, we can see a much greater area is covered. Just by making a few changes, so putting a Unilink service that goes to the rail station, for example, has a massive knock-on effect of accessibility between the two locations. So again, it's a real kind of good and unique way of using the software to get the most bang for your buck for your bus services. So these are the type of things that effectively universities love doing, just producing, as you can see there, it's very easily able to see the differences in transport modes and travel times by walking, cycling to each of the sites as part of that. Or what you can do is you can take them type of maps you've seen and we can take it to the next level, so we can then produce a database of these results. So a database showing all of your origins, all of your destinations, so postcodes to all of your campuses, and then start providing walking travel times, cycling travelling times, and public transport travel times as well. And this can then give you the basis to do much more detailed analysis. And this leads us into our first case study, which is start looking at car parking permits. So this is something that, while it's not quite universities, it seems to resonate a lot when we chat to universities about this. So they have a problem at Oxford. They're a growing trust. There's more and more people needing to use their services. But the problem with that is they need to get more and more staff, and so there's more and more pressure on parking. So what they're now doing is going further afield to get staff to come. But the problem is everyone's kind of driving in. It was causing a mess. So people were blocking emergency access. People couldn't get into the sites to meet appointments and things like that. So they had a need basically to increase active travel and to reduce congestion. That was the main kind of purpose of looking at a car parking management system. And also when they looked at doing that, they wanted to ensure they could analyse all the sites for all staff members to make sure it's fair for everyone. And as we saw about earlier on, looking at a straight line approach or a circle approach, it's not a very accurate way of looking at things. It's hard to get people to buy into it when doing that type of analysis. So then they started looking at TRACC. And the first thing they did was they analysed every postcode in about a 2-hour buffer outside of the kind of sites. And then they worked out how many parking spaces do we have, what should the cut-off times be as part of that. And they worked as a union and management to work out that actually a 25-minute cycle, a 25-minute walk, or a 45-minute public transport commute in both directions, so getting to work in the morning and getting home from work in the afternoon, would be a good cut-off to implement. Then what they did is they analysed all of these sites and outputted that out to a CSV file, and that CSV file effectively powered a HR system where people could log into the system and effectively apply for a car parking permit, which would give them a score based on travel time. So the system went live about a year and a bit ago, and straight away they noticed an immediate change in travel behaviour. So basically, first of all, people were cycling into work, people were walking into work because they had no other means of getting in as well. So this then had a knock-on effect of ensuring that red routes were no longer congested, and people were basically, there was basically less traffic on the roads. However, not everyone was happy. People did threaten to quit, but no one actually did off the back of it. But the important thing is they had a robust evidence base that they could stand behind for any type of appeals that were done. So again, they produced something that very similarly looked like this, where they had a postcode of each staff member, and then had a cycle time, a cycle distance, a walk time, a walk distance, a public transport journey time in both directions as well. And that was basically the basis of the car parking permit systems. They could then very easily say if someone was within them catchments would they get a car parking space or not. They also produced a few maps. So here we've got a map showing walking time to get to the site. So again, we've got in 5-minute bands. An interesting thing here is for John Radcliffe, actually something that's not very far away from the site, actually had quite a long walk time. So if you look near the kind of the centre of the site, there's a little estate just to the kind of southwest of that. It's actually showing a 20-minute walk time. And the reason for that is actually when you take the curvature of the road network, they've got to walk quite a long distance to get to the site. And also to the north of the site, there's a major A road that they couldn't cross. So again, that provides another natural barrier to stop people walking to the site locations as well. What you can also do is you can start plotting your postcode of your staff members and showing them actually what their public transport commute time is. So here we can see anything in green, a staff member can get to the site within a 45-minute commute. Anything in red was over 45 minutes. And then when you start looking at places like Abingdon, where half people are within the 45, half are without, you start looking at making changes to the network like we spoke about earlier on, which could then try and improve accessibility to the main site location. We've got a great quote on our website saying that how actually bringing TRACC helped people travel different ways into work. They generated income from doing that. They invested in showers as well. So it's a really, really good kind of accurate way, and it's really worked out well for them. And as I said, we've got a great case study on our website. To find out more, please log into the link at the bottom of the page. So one other thing it's worthwhile noting as well is there's a very kind of defined approach. You've got the stick approach, where you're forcing people to change the way in which they travel. We've also had in Staffordshire a way in which they're using the more carrot approach. So what they've done in education here is they provide all new students, in this example for primary schools and secondary schools, a walking zone map. So as soon as they start the school, they get a map that basically says, if you live within this area here, this is how far it takes to walk. So it then straight away promotes kind of the active and sustainable travel way. And actually they noticed straight away by doing this to all the new starters packs, they had a 27% increase in active travel, which is really kind of good news for not a lot of investment and not a lot of work at all. And this is something that could be very easily replicated, I think, for freshers as they start university or anything like that as well. The final thing here is we're starting to work hopefully a bit with British Parking Association. So I'm not sure if anyone on this webinar is attending the meeting in Leeds on 29th of June, but we're going to be there presenting a very similar presentation to this, and just trying to find out more about the kind of pressures that other people are having in university around parking and finding out how our TRACC software can help. So thank you very much for your time listening today. If you want any more information on a copy of the slides, please email in to info@basemap.co.uk. If you want to find out any more, please have a look at our website. We've got lots of lovely case studies and information on there. But thank you for your time and enjoy the rest of your day.